Hello, good class. Today we start Chapter 8. Chapter 8 is all about functions. And I'm going to like you guys to at least make sure you have your paper out right now and you're writing down the section title, Equations in Two Variables. Today's lesson is relatively easy and the homework should be finished by the end of the period. There isn't that much to this. But I do want to start with the difference between one variable equations and two variable equations. So we're going to create two columns, one variable, if I can spell that right, and two variable. And at least on the left, let's put down some examples of some one variable equations. We have ones that are not solved, and we have ones that are solved. But they're still equations with one variable, and the rest of those numbers are constants or unknown. We don't necessarily need to have the variable raised to the first power. We could have a quadratic, like x squared plus 2x plus 1 equals 0. One of the things to keep in mind about equations is that equations always have equal signs. We could go into further detail and talk about open sentences that have equal signs, less than, greater than, less than or equal to, or greater than or equal to, but for now we're sticking with equations. Those are examples of one variable equations. We also have two variable equations. Two variable equations are where we're going. And typically with our two variable equations, we're going to stick with x and y, just to have a standard system. That does not necessarily mean you need to have only x and y, but for now, x and y. So here's an equation. This is the equation of a line written in standard form. 4x plus 3y equals 2. They don't necessarily need to be linear. We could have x times y equals 7. We could have the equation of a circle, x squared plus y squared equals 36. You don't need to know what these equations are for, but what you do need to recognize at least is that in the right sense, we have two variables. And again, that's where we're going. So basically, on the left, I'd like you to write down something about the solution to a one variable equation. Is a number. It's a single number. Or I guess you could have more than one solution necessarily. For example, with a quadratic equation, you can certainly have more than one. But for a two-variable equation, our solution is an ordered pair. For example, -1, 5 would imply that x was equal to -1 and y was equal to 5. Expanding on that further, let's do a little definition. A solution to a two-variable equation is an ordered pair. While some of you are taking the time to catch up, let's at least talk about the difference between an ordered pair and a non-ordered pair. You see, an ordered pair is where the order is important. This -1, 5 example that we did up here, we were implying that x was -1 and y was 5. If we switched those and made it 5, -1, we would then be switching which one was x and which one was y. So the order is important. One of the first type of example problems we can do is just to simply ask the question, is the ordered pair 5, -1 a solution to the equation x minus y equals 4? I'm going to give you guys about 20 seconds to do this one. Plug in 5 for x and -1 for y, and just see if it's true. Okay, maybe it won't take 20 seconds. We substitute 5 in for x and substitute -1 in for y. You see that we get 5 plus 1, which is not equal to 4. So, no. Your next task would be to create an equation of which 5, -1 is a solution. How many possibilities could you have for this? My guess would be infinite. Why don't we just say 5 times 5 plus 6 times -1, and then just figure out what that would be. 5 times 5 is 25, plus -6, 19. So we can say 5x plus 6y is equal to 19, and we know that 5, -1 is a possible solution of that. Another part of this that's really important is to be able to solve for y. One example I could come up with would be 5x minus 2y over 3 equals 6x minus 7y over 4, and solve for y. This just means you want to get y by itself. Now, if you remember, we have two strategies for one like this. We could either find an LCD of 12 and multiply both sides by the 12, or because you have two fractions across an equal sign, you can cross multiply and set the two cross products equal to each other. You can only do this if you have two fractions across an equal sign, but in either case you get 4 times 5x minus 2y equals 3 times 6x minus 7y. 20x minus 8y equals 18x minus 21y. You get 2x is equal to, we add 8y to both sides, we get -13y. Divide both sides by a -13 because it's y that we're trying to isolate, and you get 2x over -13 is equal to y. So you've done it, you've isolated the y. This could be important because in one sense, this word function, which we're going to be getting to for the entire chapter, a function can be considered an equation that is solved for y. That's a very simple way of looking at a function, and it certainly won't be true for all types of functions. But if we're talking about a basic two-variable equation, it's an equation that is solved for y. In other words, it is solved for the dependent variable. Now, this year I told you about the difference between independent and dependent. You've certainly gotten this in biology. Another word you could use is, say, solved for the responding variable. Remember, the other terminology we talked about was manipulated variable and responding variable. This way, you can input something into the x and get something for the y out. I don't want to get too ahead of ourselves. We're really done for the day. The homework, which I'd like you guys to get started on right now, and there's no reason you shouldn't be able to finish it by the time the class is over, is page 351, 1 through 12, all, and then skip all the way ahead to 37, 39, 41 through 43, all. Good luck, and I will see you tomorrow.